Welcome to Circuit Secrets. In this video, I'm going to show you how to build a multi-tone Arduino Nano tone generator. A multi-tone signal generator is a useful tool for aligning, peaking, and tuning radio transmitters such as CB radios. A single tone is sufficient for AM, but multi-tone is required for sideband transmitters. This project uses the tone function and a simple trick to generate multiple tones at once. If you enjoy this content, please don't forget to like and subscribe. Here are the parts I used to build it. You can make it more complex or simplify it if you only need to work with AM transmitters. An Arduino Nano, but an Uno or Mini should work. A perf board, a 5-volt regulator. I used an LM7805. Two 25-volt electrolytic capacitors for regulator filtering. One 1 UF capacitor and one 0.47 UF capacitor. Two film capacitors for signal coupling. I used 400 volt 0.1 UF because I had them laying around. Two double pole single throw switches, but one could be single pole single throw. All I had in stock were double pole double throw. A panel mount indicator LED designed to run on a wide range of voltages. A 9-volt battery connector. A plastic project case. Some headers for the Nano if not pre-assembled. And an old transmitter microphone cable with end wired for the transmitter of your choice. I also used a zip tie and a rubber band during the construction. Once I realized how loud the tones were, I added a 470K potentiometer as a volume control. This is a diagram of how the unit is assembled. Now a walkthrough of the assembly. The Nano is positioned in the center of the board. I used a rubber band to hold the Nano and headers to the perf board. I then soldered the 4 corners of the headers to the Nano and the perf board. Now I remove the rubber band. Next, I soldered all contacts on the header to the Nano. Then I soldered all contacts of the header to the perf board. I then trimmed the leads of the headers on the bottom of the board. Next, the regulator is mounted on the side closest to the 5-volt input of the Nano. I bent the legs over to hold the regulator in place and to create rails for input, output, and ground. The filter caps are connected to the regulator as specified in the regulator's datasheet. The output of the regulator is connected to the 5-volt input of the Arduino. The 2 film capacitors are attached to digital pins 4 and 5. The opposite end of the capacitors are connected together. The wiper of a 470K pot is connected to the coupling capacitors. One side is connected to ground and the other is connected to the audio wire of the mic cable. To clarify, here is an illustration of the underside of the regulator. The center pin, ground, forms a ground bus bent towards the edge of the board and upwards. The negative side of the filter capacitors joins this bus, all in green. The input and output pins are bent away from the edge of the board. Input is purple and output is light blue. The positive side of the filter capacitors, in dark blue, are connected to input and output. As each ground connection is added, they are attached to the top of the ground bus, indicated in green. The power indicator LED is connected to the 5-volt output of the regulator. The ground of the LED is connected to the ground bus. The input of the voltage regulator is connected to a switch, and from one throw on the same pole, the positive lead of the 9-volt clip is attached. The ground of the battery clip is connected to the ground bus. A ground is attached to the other pole of the power switch, and to a throw is attached the transmit wire from the mic cable. This allows the generator to be powered up and a radio to be keyed with one flip of a switch. The pole of the other switch is wired to digital pin 3 of the Arduino, and the matching throw is connected to ground. The program causes the second tone to be generated when a ground state low is read from digital pin 3. The ground from the mic cable is tied to the main ground bus. On to the code. This may be the smallest program I have ever written for an Arduino project. It uses no libraries and consists of a few lines of code. First, in setup, the pin modes are set. The pull-up resistor is set for pin 3. In the loop function, we find the trick I used for generating 2 tones. First, on pin 5, I use the PWM output at half the duty cycle to generate a square wave. When tone is used, it messes with the timer for some pins, but pin 5 has PWM output and uses a different timer than tone does. PWM on pin 5 of the Nano and Uno generates a 980 Hz PWM signal. This is the first signal that always outputs when the generator is running. 1000 Hz is the typical test tone for aligning a radio, and 980 Hz is close enough in proximity. For dual tones, we use both PWM on pin 5 and the tone function on pin 4. Next, I perform a digital read of pin 3 inside of a if statement. I use the not operator to make the condition true if pin 3 is low. If pin 3 is low, we create a tone on pin 4 of 1400 Hz. If pin 3 is high, the tone is stopped in the else statement with the use of no tone. I delay the loop for 10 milliseconds. I hope you got something out of this video. If you enjoyed this content, please like and subscribe. Don't forget to hit the bell for notifications.